The Persistence of Vision Ray Tracer, or POV Ray, is a ray tracing program which generates images from a text-based scene description, and is available for a variety of computer platforms. It was originally based on DKBT-RACE, written by David Kirkbuck and ALll Collins for the Amiga computers. There are also influences from the early ALll ray tracer contributed by its author Alexander Ensman. POV Ray is free and open-source software with a source code available under the AGPL v3. Many methods for generating the 3D models are used, including a companion program Ray for interactive modeling. History: sometime in the 1980s, David Kirkbuck downloaded the source code for a Unix ray tracer to his Amiga. He experimented with it for a while, eventually deciding to write his own ray tracer, named DKBT-RACE after his initials. He posted it to the You Can Call Me Ray bulletin board system in Chicago, thinking others might be interested in it. In 1987, ALll Collins downloaded DKBT-RACE and began working on an x86-based port of it. He and David Buck collaborated to add several more features. When the program proved to be more popular than anticipated, they could not keep up with demand for more features. Thus, in July 1991 David turned over the project to a team of programmers working in the Graph Dev Forum on CompuServe. At the same time, he felt that it was inappropriate to use his initials on a program he no longer maintained. The name Star was considered, but eventually the name became the Persistence of Vision Ray Tracer, or POV Ray for short. POV Ray was the first ray tracer to render an image in orbit, rendered by Mark Shuttleworth inside the International Space Station. Features of the application and a summary of its history are discussed in an interview with David Kirkbuck and Chris Kazin on episode 24 of Floss Weekly. Features: POV Ray has matured substantially since it was created. Recent versions of the software include the following features: a Turing-complete scene description language that supports macros and loops. Library of ready-made scenes, textures, and objects, support for a number of geometric primitives and constructive solid geometry, several kinds of light sources, atmospheric effects such as fog and media, reflections, refractions, and light caustics using photon mapping, surface patterns such as wrinkles, bumps, and ripples, for use in procedural textures and bump mapping, radiosity, image format support for textures and rendered output, including TGA, PNG, JPEG among others, extensive user documentation. One of POV Ray's main attractions is its large collection of third-party support. A large number of tools, textures, models, scenes, and tutorials can be found on the web. It is also a useful reference for those wanting to learn how ray tracing and related geometry and graphics algorithms work. Current version equals. The current official version of POV Ray is 3.7. This version introduces support for symmetric multiprocessing, to allow the renderer to take advantage of multiple processors. Support for high dynamic range imaging, including the OpenEXA and Radiance file formats. Improved bounding using BSP trees. Some of the main features of previous release, extends UV mapping to more primitives. Adds 16 and 32-bit integer data to density file. Various bug fixes and speed-ups. Improved 64-bit compatibility. In July 2006, Intel Corporation started using the beta version to demonstrate their new dual-core Conroe processor due to the efficiency of the 3.7 betas SMP implementation. Primitives equals. POV Ray, in addition to standard geometric shapes like tori, spheres and height fields, supports mathematically defined primitives such as the isosurface, the polynomial primitive, the Julia fractal, the superquadratic ellipsoid, and the parametric primitive. POV Ray internally represents objects using their mathematical definitions. All POV Ray primitive objects can be described by mathematical functions. This is different from many 3D computer modeling packages, which typically use triangle meshes to compose all objects. This fact provides POV Ray with several advantages and disadvantages over other rendering/modeling systems. POV Ray primitives are more accurate than their polygonal counterparts. Objects that can be described in terms of spheres, planar surfaces, cylinders, tori and the like are perfectly smooth and mathematically accurate in POV Ray renderings, whereas polygonal artifacts may be visible in mesh-based modeling software. POV Ray primitives are also simpler to define than most of their polygonal counterparts. In POV Ray, a sphere is described simply by its center and radius. In a mesh-based environment, a sphere must be described by a multitude of small polygons. On the other hand, primitive, script-based modeling is not always a practical method to create objects such as realistic characters or complex man-made artifacts like cars. Those objects have to be created in mesh-based modeling applications such as Wings 3D or Blender and then converted to POV Ray's own mesh format. Examples of the scene description language. The following is an example of the scene description language used by POV Ray to describe a scene to render. It demonstrates the use of a background color, camera, lights, a simple box shape having a surface normal and finish, and the transforming effects of rotation. The following script fragment shows the use of variable declaration, assignment, comparison and the while loop construct. Modeling. The POV Ray program itself does not include a modeling feature. It is essentially a pure renderer with a sophisticated model description language. To accompany this feature set, third parties have developed a large variety of modeling software, some specialized for POV Ray, others supporting import and export of its data structures. A number of POV Ray compatible modelers are linked from povray.org, modeling programs. In 2007, POV Ray acquired the rights to Murray, an interactive 3D modeling program. Software. Development and maintenance. Official modifications to the POV Ray source tree are done and/or approved by the POV team. Most patch submission and all bug reporting is done in the POV Ray news groups on the news.povray.org news server. Since POV Ray's source is available, there are unofficial forks and patched versions of POV Ray available from third parties. However, these are not officially supported by the POV team. Official POV Ray versions currently do not support shader plugins. Some features, like radiosity and splines, are still in development and may be subject to syntactical change. Platform support. POV Ray is distributed in compiled format for Macintosh, Windows and Linux. Support for Intel Macs is not available in the Macintosh version, but since Mac OS X is a version of Unix, the Linux version can be compiled on it. POV Ray also could be ported to any platform which has a compatible C++ compiler. People with Intel Macs can use the fork Mega POV though, as that is compiled as universal binary. The 3.7 versions with SMP support, however, are still available only for Windows and Linux. Licensing. Since version 3.7, POV Ray is released under the Affera General Public License version 3 and thus is free software according to the FSF definition. Previous POV Ray releases are distributed under the POV Ray license, which permits free distribution of the program's source code and binaries, but restricts commercial distribution and the creation of derivative works other than fully functional versions of POV Ray. Although the source code of older versions is available for modification, due to the above restrictions, it is not open source according to the OSI definition of the term. One of the reasons that POV Ray was not licensed under the Free Software GNU General Public License, or other open source licenses, is that POV Ray was developed before the GPL-style licenses became widely used. The developers wrote their own license for the release of POV Ray, and contributors to the software have worked under the assumption that their contributions would be licensed under the POV Ray license. A complete rewrite of POV Ray was discussed in 2007, with one of the aims being to switch to a free software license, such as GNU GPL v3. See also, Blender, a Euro-free and open-source software program for 3D modeling, animation, and rendering. Internet ray tracing competition has a large number of submissions from POV Ray users. Kirkithy, a Euro-free ray tracing program with enhanced SketchUp compatibility, Sunflower Euro open source rendering system for photorealistic image synthesis written in Java. Yafa Ray Euro popular free open source ray tracing engine. References. External links: POV Ray homepage, POV Ray at DMOZ.